All right, these are applications of arithmetic sequences, and you want to think of them as linear. And so this is how we start them. So we'll go back to our linear equation problems. Jimmy the Hands Bowman charges customers $5 plus $2 per minute for back rubs. So let's form a linear equation for his charging. So we know his costs are $2 per minute, right? And we can use X or T, we'll do T in this case, per minute, plus an initial cost of $5. So that is our linear equation. And so now if we were to plug in 0 minutes, we would get $5. And if we plug in 1 minute, you would get $7. And if we plug in 2 minutes, you can see that they are increasing by $2 every single minute, just like the slope says. So the cost of 3 minutes would just be adding another 2 minutes. And so we end up with 5, 7, 9, 11. This is our arithmetic sequence. So we can create a general term, which is 0, 1, 2, 3, and so on, and simplify. Okay, so what we want is a general term for this. And so when you're doing these, you don't want to think of 0, because we want our n to be our first term, right? So n is equal to 1, 2, 3, 4, and so on, right? As we keep going. And so a sub 1 then would be for 1 minute, and our cost for 1 minute was 7. A sub 2 would be our cost for 2 minutes, which was $9. A sub 3 is our cost for 3 minutes, which is $11. So what you're doing is just ignoring our y-intercept and starting it at 0. So our a sub n here is equal to a sub 1 plus n minus 1 d. So our a sub n is 7. That's our first term. And then our difference here we already knew was $2. It costs $2 per minute. So if you remember, our slope is our difference, which is 2. So positive slope, positive difference, negative slope, negative difference. And that is our general term that will create that. And now you're thinking, oh, well, we ignored 0, so how can they be the same equation? So general terms for sequences, they start at 1. With linear equations, we have a y-intercept that starts at 0. This is 0, 5. So if you were to take this equation, just to show you they're exactly the same, and expand it, our a sub n would equal 7 plus 2n minus 2, which would be 2n plus 5. It's the same formula, see? 2n plus 5, 2t plus 5. It's just two different letters. These are linear equations. So when you do these, you want to think of them the exact same way. It's just you always want to make sure that a sub 1 is 7, that we are starting with 1, 7, not 0, 5. That's the difference between linear and arithmetic sequences. Okay, so let's try one of these problems. So Mac's an investor, and he sets up an investment solution for a situation for his client that will return $5,000 the first year, $61.25 the second, $72.50 the third, and so on. That should be so on for 25 years. How much is received from the investment? And so this is a summation. If you think about it, we're going to get $5,000 plus $61.25 plus $72.50 plus and so on for 25 terms. All right, 25. So that's what we're looking for all the way to here. And so we can use our summation formula. So our n equals n over 2 a sub 1 plus n minus 1 d, and we put a 2 in there, and that is our formula for our summation. So if you notice, we need our n. We already know that. N is equal to 25. We need our a sub 1, and we know that. That's our first term. And again, that's where you want to make sure that this says 1 is 5,000. So it's 5,000 the first year. So term 1, term 2, term 3, term 4. It says 1, 5,000. It's perfect. And then a difference. So as long as there's a constant difference here. So remember, a sub 1 is our first term. Our difference is you subtract 2 of the terms. So that would give us 1,125. And now we know our slope. So from 5,000, we're going to increase by 1,125 every single year. So we plug that in, 25 years of this. So this would again be 25 minus 1, which is 24, with 1125. And we plug that in our calculator. And it gives us this, 462500, so 462,500. I've also done it with the general term. It's 5,000 plus x minus 1, 1125, so our difference and our a sub 1, so 462,500. So $462,000 and $500 for 25 years. All right, let's try another one. So it says when a parachutist jumps from an airplane, the distances in feet that the parachutist falls in each successive second before pulling the ripcord to release the parachute are as follows. So it's 16, 48, 80, 112, 144. The reason this is happening is he's accelerating as he falls, right, with gravity. So what we are given, though, this is 1 second. This is 2 seconds. So it's giving us our terms. We have a nice 1, 16, right? That's our first term. So a sub 1 is 16. And then if we want to find the difference, we just have to subtract them. So that's 32. So our difference, you could see, is 32. And that makes sense. If you remember, acceleration constant of gravity is 32 feet per second. That's our acceleration. So they're going to fall an extra 32 feet every single second, an extra 32 feet. So first second, he fell 16. The second he fell 48 more feet, and then 80 more feet, and then 112 more feet. So this is a summation if we look for the total distance fallen. So they're looking for S sub 10. So this is 10 over 2 to a sub 1 plus 10 minus 1 differences. And so all we have to do now is plug this in our calculator, and it will give us our answer. And so either using the summation formula or our summation formula, sigma notation, we end up with 1,600. So 1,600 feet. So in 10 seconds, this person will have fallen 1,600 feet. And there's how we use it. So just again, make sure that it's always first term. That's our a sub 1, should always have a 1. So if you need to convert these, make sure you always make this one 1. Where if you're doing linear equations, you want to make your first one 0. Thank you.